Yes, hello everybody. Here we are going to discuss today a problem based on Coulomb's force, but here we have continuous charge. I had discussed several problems based on Coulomb's force or electrostatic force in my previous videos. Those are based on discrete point charges, but here I'm discussing force between a point charge and a continuous charge distribution. Before this video, I had discussed this problem in my last video where this is continuous charge distribution having linear charge density lambda. This is another positively charged point charge and we have to find force between them. This time, this is my second video based on continuous charge distribution where I calculate forces between a point charge and a continuous charge distribution. But these two setups are quite different. Here, from here to here, all the charge distribution is positive only, having linear charge density lambda. But here, charge density is positive up to here, and from here, charge density is negative. Both have same linear charge density. This is plus lambda, this is minus lambda. And these two conductors are attached there by some insulating support. We have to assume this problem. So this is our problem. What I'll have to do? We have to find force exerting over this positive charge by this setup or over this setup by this positive charge. And we take help from our previous problem to solve this problem so that we can consume our time. Otherwise, if I do all the calculation directly here, I will take more time. So here, I use the concepts used in this problem to solve this problem. We reduce our time of solving this problem. Let's start how to solve. I have analyzed the problem and I have also analyzed that I take support, I take help from this problem to solve this problem because in my last video I discussed this problem and the result is this. So first do qualitative analysis. Let's see in this problem. In this, I'm taking support from here. In this problem, this is linear charge density lambda uniformly distributed over a conducting support. Actually, this is an arc being cut from a circle or being cut from a sphere, making total angle 30 here and 30 here. Actually, this is arc of a circle. This is 30, this is 30. This is positive 30, this is negative 30. And I use this concept. This is the result. Direction of the force applied over this positive charge by this segment is in this direction. So by Newton's third law, equal and opposite forces exist within a setup. So this charge also exerts the same force over this charge distribution and that will be exactly opposite to this in this direction according to Newton's third law. So this is our force. If here is 60 degree, I use plus 60 and minus 60 here. This part is clear. Now I'm going to solve this problem. Here there are two different linear charge densities. This is positive lambda, this is negative lambda. This is plus q. I need to find force exerted by this setup over this charge. First take this setup. This is making 60 degree. And if I take this part separately here, so force exerted by this part, only this positive part, over this charge will be this value, this. Let me to solve this. Sine plus 30, that will be sine 30 plus sine 30. This is minus plus, so I get this 1 by 2, so it will be 1. Lambda q by 4 pi epsilon naught r. This is my result. Force by only the positive linear charge density over q is this. So I can see here that this part, center of this part is exerting force over this in this line. Let's think that at a 30 this will be center. So force over plus q by this positive is F plus. F plus is the force exerting by this positive linear charge density over q is in this direction. and this angle is 30, this angle is 30, so this angle is also 30. Now come in this setup. Now we are going to take this part to be distributing here, and by the help of this part I can find the force exerted by this negative linear charge density over this Q. I just have, because lambdas are same, I just have to alternate the values here. Alternate the sign here. For positive charge distribution we get force over Q, that is this. For negative charge distribution I get the same force but with a minus sign. So force for this negative charge density over this Q will be this, and as we can see, this is negative, this is positive, so they attract, and attractive force will be in this direction. Oh, sorry, I did some mistake here. Gate is not set. See here, the force by this negative charge distribution over Q is just this value with negative sign, and this is positive, this is negative, so the force will be attractive. So this force goes through the center of this negative charge distribution, and that will be F negative. So this is also 30 and this is also 30. Now my job has been done almost 60%. What I'll have to do to get the final force by this joint setup over this charge. By this positive setup over this Q, the force is only this. By this negative setup over this positive charge Q, the force is this. For total force by this setup over the positive Q, I'll have to add these two forces, and the addition of forces are based on vector addition. I'll have to do that. Let me trace this part, it has been completed. Take this, it's also writing total force over plus Q.
Plus Q is not visible, it's on the spot, bright spot.
Plus Q by the setup. By this setup is equals to definitely force positive vector addition. Positive. Yes, see here, the forces by positive charge over this positive Q is along this. Force by this negative charge distribution over positive charge plus Q is along this. And to find the resultant force by this whole setup over this positive Q is the resultant of these two forces, and that is along this. To find the resultant, I'll have to add forces vectorially. First value, second value square, plus 2 into first value into second value, so square. And this angle between this and these two, this is 30 degree, this is 30 degree, so this will be 120 degree. So 120 degree, and my result is this will be the force by this setup over this charge Q. My question has been finalized. I have completed this question. But there are some analysis based here. See, electrostatic forces along the line. If this charge is producing this force over this positive Q, then this positive Q is also producing the same amount of force over this charge in this direction. But electrostatic forces should be along a line. These forces are not along a line. So this setup does not produce an static electrostatic setup. This is an approximate electrostatic setup. Okay, so I have completed this continuous charge distribution.
Go.
Yes, I have finished this setup. This is an approximate electrostatic setup, not a perfect electrostatic setup, but we should solve such numerical problem. This is a continuous charge numerical problem, and anyone has any kinds of doubts, mistakes, then identify me, say me, comment me through Instagram, Facebook, and through my YouTube channel. Thanks for watching.